Alright, so let's look at the details of how we can implement a shift register on a cell matrix without using the standard approach of building a master-slave flip-flop and connecting them together, doing what we would do in a regular digital circuitry paradigm. Let's look at how we can do it much more efficiently cell-wise using a cell matrix. And we can build a single stage of this shift register out of 3 cells as follows. The cell on top will simply recirculate data coming in from the south back to the south. And the cell on the bottom will do the same thing. It will recirculate data from the north to the north. And we can also send a copy of that out to the south, just as a handy way to extract our shift register data in parallel. The middle cell will do 2 things. It will take data in from the west, and it will pass data out to the east, and the shift signal will also come in on the east, and this should get sent through to the west to propagate that shift signal. So when we make a line of these collections of cells, we can put an initial bit into the west side of the central cell. We can feed a shift signal into the right of the cell furthest to the east, and that will propagate through. And each time our shift signal rises and falls, the input bit should shift to the output on each stage, and things should move 1 stage at a time for each clock tick. And the way we can do this is as follows. We can design this middle cell based on what the incoming clock value is. So if the incoming clock is a 1, the shift signal, this cell should do the following. It should take the data coming in on the west, send it to the north, take the data from the south, latch it, preserve it back to the south, and also send it out to the east. If the incoming cell is a 0 on the shift line, we basically reverse this. We take the bit coming in from the north and we latch that, and we copy it to the south, and we send that to the output, which is the input of the next stage. So this looks a lot like the toggle flip-flop that we had without the inverter to do the toggling. So here's what's happening. We have a 0 coming into the shift input, and we have a bit trapped between the cell on top and this middle cell. This bit is circulating here, and it's also appearing on the output. When we raise the clock to 1, that bit which was originally the output and which was coming into the south is now trapped into the south, and so the output doesn't change. So when the clock rises, nothing changes on the output, but our incoming bit is now sent up to the north. When the clock drops from 1 to 0, the bit that we've been sending to the north will get recirculated down here to the south, and that will become the new output. So this is a negative edge triggered shift register. Every time the shift drops from 1 to 0, everything moves over 1 stage. And the equations from this are pretty straightforward. So for this middle cell, we can write this, if we do this in reverse Polish notation, so you can put it into the compiler. Data north is equal to west-east ANDed, north-east bar ANDed, and an OR. And if we wrote that in non-reverse Polish notation, it would be west-east or northeast bar. So the data coming to the north is either the data from the west if the east is a 1, or the data coming from the north if the east is a 0. The data to the south is almost the opposite of that, so it would be southeast and northeast not and or. So that's southeast or northeast bar. So data to the south, if the east is 1, it's just the south. If the east is 0, it comes from the north. Data to the east, this is the interesting one. This is where it actually shifts. So it's south ANDed with east and north ANDed with east bar. or together. So southeast or northeast bar. That's the same as the south. So it's the south one or the east one where the interesting stuff happens. And then just data west equals east. That just propagates a shift signal from one stage to the next. So that series of equations loaded into this middle cell, and of course this top cell is just data south equals south, and this is just data north equals north, and data south equals north. And you can load those into 3 cells and explore what happens when you hit the shift register, and you should see that that it is shifting as expected. So we'll go do that in a demo right now.